So I think let's start the webinar. People will keep on joining. Good evening and welcome all to the webinar. First of all, I would like to thank you everybody for joining us on today's webinar. So my name is Rishika Omar and I'm the marketing specialist for DevOps University. I'm going to take few minutes of your time to explain you the ground rules and give you a quick introduction about what our company does, what we are, who we are, and then I'll give a quick introduction about the trainer, the agenda for today's webinar, and then I will hand it over to our trainer to take this further. So we have set certain ground rules for this webinar. You all are on mute mode and you will be unmuted at the end of the session for the question answer round. In case you have any queries in between of the session, you can type your queries. You have the option of typing your query in the chat window and our experts will answer it as soon as possible. So there'll be this webinar will be recorded, and we will be sending you the recording link over the follow-up mail, and you can also view the recording over the YouTube channel. You can subscribe our YouTube channel for accessing the recording of this webinar. So now I'll give a quick introduction about the company. We are globally recognized and the most trusted DevOps certification provider. We design DevOps certification program and awards accredited certificates. Basically, our concept is to provide experiential DevOps learning for IT engineers and other IT professionals. Apart from this, we also provide career counseling, mentoring, and training to fresh graduates, postgraduates from different universities across the globe. So if you want more information, we have so much of information available on our website. We have tutorials, setup guides, and various blogs on the various topics. If you want to learn new things on the topic, you can visit our website and access the free material over there. So this is the slide wherein we are going to tell you that we are offering 10% instant discount on the course fees. So cost of the program, which is currently is $295 US, and today we are running an offer for the webinar attendees. That is, we are offering 10% discount on the cost, which is already discounted. So we are again giving a 10% discount on the above costing. So the link will be shared to you over the chat window, and you can click on that link. Go to you can go to our website and apply for the course, and you'll get the instant 10% discount on the same. Coming to the next slide, our next batch is going to start from 14th of May. Those who wants to enroll for the course for next batch, they can this offer is valid for today and tomorrow both. So you can avail this offer by tomorrow. If you want to decide and enroll by tomorrow, you can do that. Coming to the trainers interaction. So basically trainers are the real-time industry practitioners who are having very rich experience of close to around more than 10 years on this technology. So without any further ado, I would like to hand it over to Anuj to take this further. Anuj, you can take the agenda forward.
Sure, thank you so much. Welcome everyone to this webinar here. So I hope the agenda is already clear that we are going to talk about some of the topics about the microservices and the containerization over here. What's the relationship? What's the difference? And then I'm also going to explain you a small example with a live demo that how the applications gets deployed in the form of containers, how we have our applications hosted in the form of containers, how we're going to build out there. So those stuff we are going to talk about so that we can have a basic understanding about these different concepts and we can have end-to-end functionalities considered over here. Right. So I'm just going to quickly share my screen.
Sure.
and just let me know in case you see that part. Now, so now when we talk about the microservices and containerization, there are some small myths which is available in the industry. For example, a lot of people in the industry think about that microservices and the containerization is interconnected, or they are like dependent on each other. But these two are totally different processes which is available there. Yes, definitely the microservices and the containerization is quite compatible with each other, and we think it up only purely from the compatibility perspective, because it's not like if you're going for microservices, then we are going for the containerization also as a mandatory stuff there. So we have a kind of compatibility which is available there, but there is no hardcore dependency which we need over here in this one. Now, when we talk about the microservices, it's a very like a important phase of performing the development in the organizations. In fact, that when we work in the actual organizations, we have a lot of new trends which is coming up, which really helps the organizations to design new technologies and go around the new infrastructures there. Now, for a very long period of time, the development teams were following different mechanisms or different way of performing the development, but not anymore. We are having some new standards available right now, which is talking about the microservices, containerization, and these standards are very important for hosting the applications effectively. So that's a kind of implementation which is being considered by these different technologies here. But yes, microservices and containerization is very much important, and a lot of people are actually using this so that they will be able to get the functionalities. Now, if I want to give you a very high level of understanding about the microservices, so if you can see here that we also have a comparison between the monolithic and the microservices over here. So in this case, what happens is that we have basic stuff that how these things are going to work, and how the implementations are going to be considered here. Now, in this scenario, you can see on the left hand side we have the monolithic architecture which is available there, and on the right hand side we have the microservices architecture which is available there. Now, when we talk about the monolithic architecture, so in monolithic architecture, what we try to perform is that we try to see like how these setups are going to be done, and how the executions is going to be performed over here. So here in this case, on the left hand side, you will see like the user interface, the business layer, the data interface. So you can see like there are like different interfaces which is available there, in which you are going to deploy your application, your web application here. So there are like different mechanisms using which you can try to understand that how the implementations are really going to work, and how the setup is going to be conducted over here. So that's what we are trying to do. We are trying to host when it comes to the monolithic architecture. On the right hand side, we have the microservices architecture, but that's something which is totally different there. For example, if let's say there is a problem in a monolithic architecture, there is a problem with the user interface, there is some issues which is available in the business layer, or if there is any particular issues in the data interface. So what happens is that we are like facing some issues. So the whole applications will be down, because in monolithic architecture, the applications are tightly coupled with each other. They are like very much integrated with each other. So if you're doing any kind of a changes in one component, the other component will also be changed, and will also be causing the trouble over here. So this is a normal nature that how a monolithic architecture really works. And the only problem with this monolithic architecture is that they are so much dependent on each other, that if you are doing any kind of a changes on one component, the other components is also going to be impacted over here. So that's a biggest drawback or issue which we are like talking about in monolithic architecture. And it was also known as the legacy way of designing the application. We used to say that the applications are so bulky in nature, like they are like in huge MB in size, they are in GBs in size. So they have such a huge amount of storage which is available there, and sometimes it becomes very difficult for someone to actually go and implement those stuff as such there. So that's a kind of a way that how in the legacy world, or in the legacy architecture, people have designed, have developed the development processes, and proceeded with the overall development processes over there. But when it comes to the monolithic architecture, you can see that the biggest benefit we are getting over here is that in monolithic architecture, we are like having like a kind of a performance. And monolithic architecture, we are like having small microservices which is like interconnected over here. And if you're doing any kind of a changes in one monolithic application, so there will be no impact on the other monolithic applications. And then definitely like you will be able to see like how the implementations are going to work, and you will be able to get the executions right away over here in this one. All right. So microservices architecture is also something using which we will be able to see that how the implementations are really going to work over here. Right. Now, what are the different advantages of microservices? Microservices, one of the biggest advantages that, okay, of course, the dependency is something which is, like a removed. There is no dependencies available there. That's a good thing. Second, if one microservices wanted to develop in Java, another microservices needs to be there in .NET, or another microservices is going to be deployed into a particular Android or Python or something like that. That's all the possibilities are available there. And we have that option. We will be able to go with that because there is no dependency that all the microservices needs to be designed only in a single programming language. We can have multiple programming languages also, using which we can go and we can implement the stuff. That's another thing. Another benefit which you're going to get over here is that when you talk about here, so the each and every microservices can actually have its own databases also. So if you feel like rather than having a single database, you want to have multiple databases for each and every microservices, or a group of microservices can have a kind of a database. So that's also like something which is quite possible with the help of microservices architecture here. Microservices is nowhere related to the containers. We are not specifying or saying over here that microservices is having any kind of a relationship with the containers here. It's a very basic process, or we can say that it's a very basic way of performing the automation, in which we can go and we can perform the implementations and the setups all together in this one. So that's a kind of a benefit which we are like getting when it comes to the microservices architecture here. So it's just a way that how we are doing the development, how we are performing the implementation when it comes to the microservices as such over here in this case. All right. So when you want to host your microservices, you have a choice where you want to deploy it up. For example, in my organization also, we migrated from the monolithic to the microservices architecture. So in that case, what we did is that we pretty much went with the process where we, specified that how the microservices are going to work, and it's going to help us to go for the processing. So what we perform is over there is that we talked about it how the things are really going to work, and we will be taking care of the functionalities, and have the implementations conducted there. So with the microservices, what we can do is that we can go like how we can implement it up there. You want to host the microservices on Tomcat, Apache, WebSphere, or WebLogic. That's all the possibilities which is available, and you will be able to conduct or have those particular setups conducted there. So it's your choice that how these implementations are lately like you are trying to perform, and you are trying to integrate over here in this case. Right. Now, second thing is that what's the relationship between the microservices and containerization? See, when you're talking about the microservices, it's just a way that how you're going to convert your application into microservices here. That's a small, or that's a basic nature of performing the implementation. But if where you want to host these microservices, you have a still you have a choice. You have a choice that whether you want to host this one onto a particular like onto a is virtual machine, the WebSphere, WebLogic, or if you want to host it up or launch it up onto a particular onto a Docker container. So you have these different options which is available, using which you will be able to perform and automate the things and the scenarios here. So that's a kind of implementation which you are trying to do, and you are trying to implement it up over here in this one. So that's a kind of a scenario which is considered over here. So with this one, what will happen that you will be able to see like how this automation is really going to work and gets the implementations conducted here. Right. So this is the way that how the microservices is going to be conducted, and we will be able to get the proper executions back over here. Now, Docker is one of the another like a solution which we can use. Like if we really wanted to host our applications or host our app microservices, so Docker containers is also one of the solution which is available there, using which we can see like how the implementations we want to do and we want to conduct over here. So that's also like one of the way that how we are going to perform the automations and the integrations here. So when we talk about the microservices or this architecture, so we will be able to see like how these are being implemented, are being launched right away over here in this one. So Docker is a virtualization software. We call it as a virtualization software because it's having a lot of like a kind of a similarity with the actual virtualization there. But here, the only difference is that the Docker is something which requires an operating system, and using that operating system only you can go and implement the automation. So Docker is a platform as a service solution which is being used to deploy or host your applications. Now, Docker containers is not something which we can host or deploy onto a operating system. We onto a bare metal server. We need an operating system. Then only we will be able to go and implement the stuff and implement the setup here. So that's a kind of process which we are going to see, so that we will be able to get the proper mechanisms as such. Right. So Docker is one of the most popular containerization tool technology which is available, using which we will be able to see like how the implementations are going to work, so that we will be able to get the expected results back over here in this one. So it's an operating system level virtualization, which is going to help you to implement all those considerations. Now, when we talk about Docker, so Docker is deployed on top of an operating system. For example, whether you have a Windows machine or a Linux machine, so Docker is something which you have to go and you have to implement, so that you will be able to set up your applications. Now, what is the reason why people are going for the Docker in the first place? The first reason, we have already talked about that microservices is the requirement that we have to anyhow go and implement the microservices architecture, because microservices is having a preference that if you want to deploy, so you will be deploying it up a Docker container. So that's one thing which you will be deploying, so that we will be able to see like how the implementations are going to work, and we will be able to get the expected results back over here. Right. Now with this one, what will happen that we will be able to get the overall implementations and the setups conducted over here. Another thing which we have is that Docker was also like started as an internal project only. It was not something which was meant to be there in the industry, but yes, it was started up as a basic project, and then over the period of time it became a kind of a popular tool in the market for hosting the applications. Now, without Docker, what you're doing is that if you want to deploy, let's say, a Java application, so you have to install the Java runtime, and then you will be installing the applications. But with the Docker, you have a benefit, you have a leverage that both the kind of both operating system, application source code, or any kind of a binaries or executables, everything will be embedded inside a single Docker itself. So that's a kind of a benefit which we get with the Docker, that you don't have to really go or perform any kind of separate implementations. All you have to do is that you have to go and implement the Docker, and this one will help you to host your applications code bases, everything inside that. So that's a kind of a benefit which we are talking about over here. So Docker is a very not a very old tool, but yes, it's there in the market from 2013, and from there people are using it. Earlier it was just a community version, but later on then it just became as in particular enterprise solutions, and step by step, we have got this Docker solutions available which we can use nowadays. So it's like a enterprise solution which we can go and we can utilize the stuff there. Right now. Right here. No. Now this is the basic architecture of a Docker. Docker is not a kind of a complex component here. So a lot of people in the market say that Kubernetes is something which is a substitute of Docker, but Kubernetes is a kind of orchestration tool which is available there, using which we can manage our implementations, like using which we can go and see like how the implementations are really going to work. But yes, it's a kind of a tool, an orchestration tool, which is used to manage the Docker here. But Docker all along, it's also a kind of individual tool, which is really going to help you to see like how implementations is being done, and we get the application hosted there. So whether you want to use Docker or you want to use the Kubernetes, it's up to you. But yes, both of them are like the options which is available, using which you can go and you can implement the stuff. Right? So you have a client, like when you install the Docker, so you have a client which is going to take care of the request. There is a Docker daemon which is going to process the request, and it's going to take care of all the requests which is being sent by the Docker client. Once this Docker request is being processed, so you will be having like Docker containers and Docker images there, so that will be deployed. And then ultimately we have the Docker Hub where like you will be uploading your Docker images. So it's a third-party cloud solution where you can go and see like how the implementations are going to work, and we will be able to get the expected results back over here. Right now. Now, if I talk about it, how a particular, I'll just come back to the previous slides, but this image I just wanted to show you because it's a very important thing to understand that how the applications gets packaged. If you can just see over here that, when you are talking about the implementations or the setup. So here we have different containers, like you can see that there is a particular one container available here. This is second container, third container. So when we talk about Docker, so the biggest benefit of Docker is that in this one, both the dependencies and the application code, we actually go and we can deploy into a container. That's what we call it as a container here. So in this one also, you can see that one container is like in this, we are taking up a Debian operating system. And then on top of that, we are deploying the Java application. And then on top of that, we are going for the Tomcat setup there. So this is how a typical application gets hosted, like one by one. Different components are going to be available there, so that you will be able to see like how the different processing are going to work, and we will be able to get the configurations in place. Now the second one also, you can see that we have the container. This is another container which is available, where we have the SQL Server, we have the .NET, and we have the Ubuntu available there. And then the last one, you can see that there also you have the another container where you have the Albino operating system, then the static binaries, and you can have that operating system conducted there. So both the application source codes and the dependencies are what like you're trying to put up. You are going to store into the component here, and using this, you will be able to see like how the implementations are really going to be conducted over here. So that's a kind of setup which is going to be considered, so that we will be able to see like how these implementations are going to be performed here. So whenever you go and prepare or try to host or bundle up your application inside the Docker container, so in that case, you actually use the mechanism like this, where you are going to not only package the operating system binaries, but you also go and deploy the application source code here. So that's a kind of a benefit which we are like talking about over here when it comes to these setups and the integrations as such. Right, so this is how it happens on a particular Docker engine. You may have different containers deployed, and then in that particular container you will be having the applications deployed. It can be any application. It can be a Java application, .NET application, or the Python, or any kind of a application. You can go and you can deploy it up over here in this one. All right, so this is a way that how the different applications we get deployed as in form of a containers, and in a particular host or a server, you will be able to see like how the implementations are going to be conducted and get the specific desired values right away over here in this one. All right, now, yes, now so far we have talked about that. Okay, Docker is giving us some couple of benefits. You don't have to install any dependencies. You will be able to package both the dependencies and application code as a single container. So you have seen all these different benefits there. One of the another benefit which we are talking about in Docker is that Docker follows build, ship, and run mechanism, which means that if you're going to build out a custom Docker image, like using the Docker, if you're going to build out a Docker image, then that Docker image is something which you can host or deploy on any platform, on any environment. It's not like only on a specific host only or a server only you will be deploying or you will be hosting that particular application here. For example, if you feel like you want the same Docker image to be deployed on all the environments or multiple environments, all that things is possible. It follows a ship mechanism. You are doing a build of Docker image, then you're uploading to the Docker Hub. Then you can deploy it to any platform, whether it's a dev environment, whether it's a test environment, or if it's a pre-production or a production environment. It's a possibility that you will be able to deploy and host your Docker containers on that particular server. This is also one of the benefits that you don't have to perform a rebuild activity for each and every environment. Once if you have done the build, then the same build you can go and you can deploy across different environments. You don't have to do it again and again or separately altogether. So this is also one of the benefit which we talk about when it comes to the Docker, that the build time duration which is being taken for different environments is going to be reduced, and you will be able to get the expected results back over here. All right, so this is a very important stuff because so far we were like doing the builds in a different mechanisms, but yes, using this, what we can do is that we can do a build once, and then on multiple times or multiple locations we can go and we can deploy it up there. So we don't have to perform any kind of a setups. So you do it build once, and then you can upload it up to the Docker Hub, and anywhere if you feel like you want to deploy a host, you will be able to host it up or deploy it up over there. So that's a kind of a motto which is being there behind the Docker, that how exactly you're going to prepare and have the different Docker images built out, and you want to deploy across different environments. You want to deploy on AWS cloud, Azure cloud, on premises, private system, wherever you feel like you want to go and implement, you will be able to get the expected results back over here. All right, so this is a very important thing, and that's a reason why Docker is being one of the most popular there. Now, another reason which we prefer that why we are going for the a Docker here, because there is no one single reason which we can specify that why in the first place we are going for the Docker. There are multiple reasons, and so far we have already talked about that stuff. But if you closely see over here, if we talk about the difference between the containers and the virtual machine, so what happens is that we have a precise difference that how we can talk about that what's the primary difference between the virtual machines and the containers over here. So with this one, you will be able to see like how the overall implementations we will be able to go, and we will be able to get the expected results back over here in this one. All right. Now, what happens is that when we talk about this setup here, so on the left hand side, again, you have the Docker, and the right hand side, we have the particular virtual machines here. Now, I'll tell you exactly the same difference, the precise difference which we have got over here. Now, when we talk about the virtual machines and the Docker containers here, in case of a Docker, what happens? We have an infrastructure, we have the host operating system, and then we have the Docker which is available there. And then on top of that, we are like going for the binaries and applications. We are installing the binaries and we are installing the applications. But the thing is that in this one, we are like trying to utilize, we are trying to use that how exactly these Docker containers are really going to work and they are going to function here. But on right hand side, we have a totally different thing. We have a guest operating system. Now, the reason why people are going for the Docker in the first place from the virtual machine, because virtual machines are very huge in size. They comes up very huge size over there, so that you will be able to see like how the executions we are going to get, and we will be able to get the proper results back over here. Right. So one of the reason why the virtual machines are not considered as a valid for hosting the applications, because this guest operating system is something which is very, very heavy in size, and it's not like something which is recommended for deploying the applications. So, this is the reason why in the first place we need to, remove, or we need to have our particular operating systems deployed there. So that's the reason why what we need to do is that we need to remove this guest operating system, which is going to take a lot of resources. So what we need to do is that we need to go and have the implementations conducted there. So we have to remove the operating system. So this operating system, which is taking so much time, we have to remove it so that at least we will be able to get the applications hosted back over here in this one, right? So that's the kind of a benefit we are talking about, that the guest operating system in case of Docker is very small in size as compared to the virtual machine, which actually, understand that how the virtual machine in the first place is causing a lot of resources utilization. And, that's the reason why the Docker containers are very lightweight there. And it's very easy. Within a couple of seconds itself, you will be able to go and build out your applications, and you will be able to get the proper executions right away over here. So that's also a kind of implementations which you will be able to conduct here. And this is also one of the reason. Now, this is not a small reason, this is a very important reason, because with this one only we will be able to reduce a lot of our IT costs there. Because if I have a server and on which I can only deploy one application, but with the Docker I can have more than one applications deployed, so definitely you will be able to have a lot of implementations conducted. So this is one of the preferable reason why people should go for the Docker, and why there is a huge movement or a huge implementations going on the Docker perspective. Right. Different organizations, there is no compulsions that only a certain industry need to implement, need to go this one here. But again, it happens that every industry, every organization is using this one, whether it's a financial, whether it's insurance, technology, public sector, financial services. In fact, organizations like NASA is also like using the containers and the Docker perspective. A lot of defense equipments where we are like, for example, jets. The Docker containers are getting deployed. Kubernetes is being used in that sense. So there are a lot of applications which is available in real time, which is going to use like these implementations, and we will be like going up with those particular setups there. So there are like a lot of solutions which is there, so that we will be able to see like how the implementations are really going to work right now. Now let me show you a small demo on how the Docker is being defined over there. So what I have is I have a Git repo which I can show you to understand that how the particular things are going to perform. Let's say I have a web application. I have a Java source code which is available there. This is a kind of a repo which is having the source code. Now in this repo, we have the source code which is available there, where we can see like how we can store the source code. So this repository is just a source code which is available, and we have to containerize it, right? So this is already a microservices which is available, and we what we want to do is that we want to make it up as a containerization, which means that we need to deploy this application as a Docker container here. So that's what precisely we are going to do. We are going to perform over here. So in this one, what happens is that we have a particular specifications. For example, we have the kind of a Java source code which is available there, so that we will be we will be able to do this setups and the conductor and the modifications. Now we have a Docker file here which is known as the build script. Now what is a further now? You can see here, this is my Docker file looks like. It's taking like it's a kind of a Docker file which is available, using which we can see like how we can perform a build out, like a custom Docker image we are going to build, in which not only we have a basic environment, but the application source code we will be also able to store, and we will be able to locate over here. So we want to make a complete bundle. When we talk about it, we want to deploy an application on Docker. So we need a Docker container preparation, and how we prepare a container by bundling up both the application source code and the operating systems together. That's what we try to implement, and we are trying to integrate it up over here in this one, so that we will be able to get the expected results back over here. So that's a implementation which is needed to be conducted, so that we will be able to get the results back over here in this one. So for example, here I'm saying that, okay, Java is the basic image I want. I'm storing my applications, my Java source code there, and I'm just trying to run it up over here in this one. So when I'm going to prepare a custom Docker image using this Docker file or using this source code, so what will happen that we will be able to have our microservices hosted inside the Docker containers, and that process is something we call it as a containerization. So one process is microservices, that you will convert your monolithic application to microservices. You may be like splitting up your big application into small applications. That's a normal development process which you will be performing. But we also have another process which is known as a containerization, under which what we do is that we try to host our microservices in the Docker containers. That's a process we call it as a containerization, because with this what will happen that our applications will be hosted, will be deployed as a Docker container. Once it's deployed as a Docker container, you can actually run it, you can deploy it, or whatever the things you feel like you want to conduct, you will be able to perform that particular stuff there. So that's why these two processes are totally different. It's your choice. If you don't want to go with the containerization, you don't want to host your microservices on containers, that's your choice. That's something which you can decide. You can go without the containers also. There is no 100% compulsion. But if you want to think, if you want to deploy your applications, your microservices effectively, then definitely in that case, you can go for the microservices, so that you will be able to get the microservices and containerization both implemented right away here. So these two processes are interrelated, definitely, but it's not like we have a dependency that if you want to achieve one, you have to go for the other one also. So that's kind of a dependency is not available here. Right. So what I'm going to do is that I'm going to see like how exactly we are going to build out. We are going to build this source code over here and host it up in a particular container so that we can get these source code deployed right away here. So that's what we are going to do. We are going to achieve here. So I'm going to I have a server where I have a Docker deployed. I've installed the Docker software over here. So I will show you like how I'm going to package this source code and a basic operating system as a Docker container. And I will be running it up over here so that we will be able to access the web application. So that's what we are going to perform here. So first of all, I'm having this source code. This is my source code. So I need to need this source code for my build out. So I'm just doing I have the source code completely available with me, and I also have a Docker file which is available. So what I need is that I need to perform a Docker build here because this Docker file is known as a build script. Just like we are using some shell scripts or some Python scripts or something like that to automate some process. So similarly here we have this Docker file which is available, which is taking care of the build automation. So for that part only we are using this stuff here. So what we will be doing is that we will be going for a Docker image build out so that once that is built out, we will be able to deploy it up as a Docker container here. So that's what we want to do. We want to conduct here. So what we will be doing is that we will be going for the implementations and we will be performing a build out here. Right now, we don't have any images available as of now, but what we will be doing is that we will be performing a build out over here so that we will be able to see how a kind of a custom Docker images can be prepared, can be built out over here in this one. So that's what we are going to perform here. So in order to perform or in order to build out a custom Docker image, so what you have to do is that you have to run a specific command and then only you will be able to get the expected results over here. For example, you're going to run a command docker root app dot. Because we will be talking about the Docker commands in a detail there, in the actual course. But yes, this is what we are trying to explain you that how we bundle up the things together and how easy is to package an application with the Docker. If you want to do the same things on a virtual machine, you may have to launch a virtual machine, get the Java installed, get the application deployed. A lot of works needs to be done there, right? Now you are getting an error message saying that no source files, which means like we are trying to transfer this jar file here, but it's not working as expected. We are not able to get this jar file, so that's not something which is able to transfer here. So we are not getting the proper results here. So we have to do a build out here. We have to perform a build out so that we will be able to have a particular jar file here. So mvn clean install maven build we require. So you have to do a maven build first, and because with this we will build only the the source code will be built out here, like because if you want to generate the jar files, var files, er files, or any kind of executables, you need to go for a build process. If you have not done the build process, you will not get the artifacts there, and your build process will not work. So it's an kind of an important thing that you need to have the build process conducted, and then only it's going to work for you. Right. So again, if I'm going to run the particular build command, it's basically filling for me for the jar file because jar file is not available there. So we have to go for the build process. Because once we are done with the build process, we will be able to have the jar file here. right? So with this, what will happen that you will be able to get a target, like a file in the target directory, which is available there. Now, if I'm going to build out my Docker image, yes, it will be done there. See, it got built out. So now this Docker image, which is available, it's having this Spring Boot app. One is something which is having the applications stored, or it's something which is going to have my applications available over here. So with this one, what will be happening is that we will be able to see like how our applications is going to work as such here, right? So this Spring Boot application is available, which we will be able to process, and we will be able to perform these setups as such here. So this is how we are going to package not only the application code, but all the binaries, executables, or whatever the other piece of software is required. That all things we are going to package and bundle up but as a single entity here. This is a single container which is available, using which we can see like how the modifications are really going to work over here in this one. That's all what we are going to do. We are going to perform here, right? So we will be having this Spring Boot app Docker image over here, so that we will be able to see like how these things are really going to work and functions as such here. Right now, for this one, what we have to run it up as a Docker container, because without this, it's not going to work. And once it's deployed, if I'm going to do a particular curl, I'm getting a response here. So Docker run, because once you have the Docker build command, using which you will be able to build out a custom Docker image. And then we have the custom Docker images built out there. So using the Docker images, you will be able to find out that what are the different Docker images you have got there. So you will be able to build out custom Docker image, and once that is built out, after that you can just simply go and deploy it up as using the Docker run command here. So ultimately, this is a kind of a sequence of commands which is required, using which we will be able to host our application in the form of Docker container here. So that's something which we will be able to do here, right? So using the Docker, what we will be able to do is that we will be able to host our application in the form of Docker, so that we will be able to get the functionalities conducted over here, right? So that's a kind of a primary benefit which we are going to get when it comes to the Docker, that you will be able to get the applications hosted, so that you can get the proper results there. So that's a kind of primary advantage, that not only you package the source code, it's not like my only source code is available there. If you look upon my Docker file, it's having both the source code, executables, binaries, everything will be available there. And that's what we are trying to look upon. And once we get that particular executables, what we will be able to do is that we will be able to deploy it up also as a Docker container. So Docker container is nothing but a running instance of a Docker image, and once it's deployed as a Docker container, you can see here that using the curl command, I'm actually trying to fetch it up there. So I'm just trying to hit on the application URL, and we are getting the expected result that yes, this is the way that how the implementations are going to work over here. All right. So this is a way that how the microservices usually gets integrated. Microservices doesn't mean that because everyone has its own role. If you are working as a DevOps engineer, the importance of microservices for you is just from a Docker perspective. If you're working as a developer, then of course you have to convert this application source code in the microservices, where you have to split the applications. And since you're working as a developer, so you will be performing those kind of activities altogether. Right? So this is a way that how the microservices are being implemented in the first place, and how we use that particular stuff. All right. So with this one, we are done with this microservices. Of course, there is a huge demand of this one, microservices and containerization, because the single hand benefit of this one is to improve the overall quality of the source code, and at the same time, the performance or the efficiency of the applications products are also increased a lot there. and the IT cost or the faster deploys. Those are the standard benefits which we get when we talk about these microservices and containerization here. So both of them, if you go and implement, that's great, but it's not like they are 100% dependent on each other.
So thank you, Anuj, for the wonderful session. And now we will be moving towards the question answer round. But before we start the question answer round, I would like to make an announcement, which I've earlier also told you, that we are running a special discount of 10% on the course fees. So, people who wants to enroll for the course, we are this discount is valid till tomorrow. So they can, visit the link which is being shared with you over the chat window, and they can avail this discount by clicking on the link. So, guys, if you want to avail this offer, you can, visit our website, apply this coupon, and you can get the instant 10% discount on the course fees. So, Anuj, you can take the question answer rounds now. We are unmuting all of you for the question answer session. Guys, you can ask one by one your queries.
Hello,
Yep, please
I'm
go ahead.
audible,
Yes,
right?
please go ahead.
I'm audible, right?
Yes, you are.
Okay, I want to ask, means I'm automation engineer in my company. So I have means, I have to now work in the micro. My project is recently is Spring Boot, right? So I want to know that microservices are hosted on Docker Hub in the form of images, right?
Yeah.
So we can means I'm confused that we can suppose I have hosted it on the Docker Hub, my own customized image. So when we are pulling the images, so we need a container ID, right?
Yes.
So means this container is independent, means we are pulling our, means suppose we have written the command that Docker pull image tag. So that image when I pull from the Docker Hub, so it's residing in our local system, or it's in the cloud.
See, the thing is that there are two concepts. One is the Docker images and one is the Docker containers. Docker images is what I have built out using the Docker build command, and it's having the source, binaries, everything available, right? And it's available on the Docker Hub. When you pull that Docker image and you run it up as a Docker container, that's where we call it as a Docker container. So the running instance of Docker image is known as the Docker container. When you do the pull command, right? So of course that's something which will be downloaded on the local machine wherever you're running the pull command. The purpose of pull command itself is that if you want to run a Docker image as a Docker container, so you have to pull it up. That's a first task. And once you got the Docker image, then of course after that you will be able to have your applications deployed as a Docker container here. So these things are interdependent, but microservices is not always related to Docker. Just like I told you that it could be a possibility that microservices may get deployed onto a virtual machine also.
Yeah, but means like that means image is like a template, like a class
Yes.
you
Yeah,
relate in the,
definitely. Yes,
and
yes.
the object we can say that which have a physical existence is a container. So
Exactly.
yeah, so I want to know that suppose I am running the image on the Linux platform and the same image on the uh, OS platform. So that both container we can do manipulation at both, means suppose I want to pull something in that customized image. Okay, so we are pulling it means we are pushing something, means we want to manipulate something in the uh, customized image. So we can suppose we are pushing at the same time from both the OS. Okay, from the Linux by using container, and from the Windows by using container. So is it possible to have different means container ID for the same image, and we can, and the manipulation from the different places?
No, see, the thing is that every Docker image will have its own operating system. Like if you want to have a Linux one, that will be separate. If you want to have Windows, that will be separate. These Docker images which you see on Docker Hub, if you want to do a customization, then using the Docker file only you can do the customizations. For example, there is a sample, like there is a Docker image which is given by your product team, which is having some basic application. Now you want to do some customization on some property files, or maybe you want to include some property files or some additional configurations you want to include. So using the Docker file, you can do the customizations on top of an existing image, right? But it's not like we can merge two Docker images or something like that, because every Docker images will have its own operating system. Which operating system you want to go, that depends on the nature of the application and the compatibility of the application. But most of the time, Linux is the most preferable operating system which is being used.
Yeah, I want to know that Docker Hub is hosted on which OS? Means it is independent of OS, right?
You don't have to worry about the Docker Hub OS operating system, because there you can upload any Docker images. It's just a registry available there, like a software. Similar to Docker Hub, there are a lot of other options like ECR is there. Azure Cloud is also providing, AWS ECR is also available there. They are just repositories available where you're just uploading your Docker images. It's not
Yeah,
like
it's
when you upload your Docker image on Docker Hub, so you're going to deploy it somewhere. So whether it's a Linux or Windows, doesn't really matter.
okay. It can deploy at any place, right?
Yep,
From
yep.
we can pull it from any place. That Docker. It's like
Anywhere.
it's like a GitHub, right? Means
It's like
repository.
GitHub, exactly, precisely. So GitHub, you don't have to worry about their operating systems. For you, it's just a repository.
Yeah, yeah. I got it now. Thank you so much.
Yep.
Hi, Anuj. I'm Raj. Hello. Anuj, am I audible?
Yeah.
Okay. So my question was with respect to the operating system. Somewhere in the documents I read that Docker works very good with respect to Linux, and there are some incompatible issues with Windows. Might be my understanding is wrong, but I just want to ask you: uh, is there anything such that Linux will work best and Windows is not like that?
What happens is that there is a compatibility issues here. For example, if you have built out a Linux container, right?
Mhm.
Now, Linux container is something which is compatible, that whether if you have a Linux virtual machine, so there, if, for example, I have a virtual machine, I have deployed Docker on top of that, so I can run the Linux machines. Okay,
Hmm.
Linux containers I can deploy. If it's a Windows machine, in Windows machine also we can actually have an option. If I install the Windows software, Docker software into my local laptop, so there also I have an option that I can run the Linux containers. But when it comes to Windows container, because Windows containers require a basic architecture, 32-bit and 64 basic Windows architecture, so that can be deployed only on Windows platform. So if you wish to run the Docker image, the Windows Docker image on a Linux operating system, it will
Mhm.
throw an error because the architecture is not compatible,
Oh, okay.
right? So
So,
that's a problem there. And but believe me, if you want to go for a Java application or these kind of things, you would not choose the Microsoft Docker images. Microsoft Docker images are only used when there is a dependencies on Microsoft technologies. Nowadays, .NET framework and all, they are also like extended to a Linux platform. So people have stopped using the Microsoft images there. But you have a dependency that if you want, then in that case, Windows machine is required.
but from the we are not mentioning any OS stuff in the Docker file, isn't it?
The very first thing, the from attribute which is there in the Docker file,
Uh-huh.
I can share my repo. In that case, I'm selecting Java image. So
Yeah.
that Java image is an existing Docker image, but that Java image is also having a OS.
Okay. That OS is a
Because
Linux.
yeah, because I'm using a Java as a base image, which is already built out by someone else, right? So when that person built out that Java image, he might have selected a specific operating system.
Got you there. Thanks for that. Yeah. Thank you.
Hi, Shyam this side.
Yeah.
Yeah, I have one question. It's like I am a QA automation engineer. So suppose I have some set of scripts, like 1,000 scripts are there. I want to run my scripts on the cloud machine, like AWS.
Hmm.
Okay, so I want to run it and split all the 1,000 scripts in multiple machines. So I don't need to run it in multiple machines. I want to run it in virtual machines, like containers. Okay. So in that case, how would I achieve it using
See, this
this?
is also a very common way that how the testers are actually doing it, because installing the required softwares on the virtual machine sometimes takes a lot of time. So rather than that, they actually go for they actually go for the Docker containers for running the test cases, and then they can just remove the containers there. So using the Docker run commands, the same stuff, you can actually go and you can go inside the container, and you can run any kind of a Perl script, Python, shell, or whatever you feel like you want to conduct. You will be able to do that. I have shared a repository just now, and in that case, you will see like in the last, in the Docker file, in the last line, if I can just share my screen here. In the last line, there is an attribute known as the entry point attribute. So here right now I'm just running a java-jar command, but there if you have a Perl command, you can run it so that when you run or deploy the Docker container, so the moment the Docker container is up and running, so this command will be executed. So if you're running a Perl script or something like that, that will be executed. And once it's done, once the execution is done, it will die by itself and give you the logs on the screen itself. So this is also a very preferable way of being, doing some kind of changes, some script executions, some codes executions. If you don't want to go for a typical virtual machine, this is a good way of doing the stuff.
Okay. So, is any difference to running the Docker, creating the Docker containers on virtual machines or cloud machines?
Yes, definitely,
Right.
because when we talk about Docker images, these are compressed form of operating systems. So there are a lot of binaries which will not be available there. For example, if you want to, in your test cases, you're running a ping command. I'm just giving an example. So in a lot of Docker images, ping command is not present. You have to install it. So before running the test cases or something like that, you have to make sure that the Docker image which you are using should have all the required executables and binaries. Then only it's going to work for you.
Okay. Okay. Thank you.
Everyone done?
I have a last question.
Yeah.
I have so basically, what's the role of means? Can you give me the roadmap? That's what's the role of Kubernetes after uh, means hosting it on the Docker means Docker Hub. I know that Docker Hub is used to create the containers, and Kubernetes is managing the container, right?
Mm-hmm.
So yeah, so how means have you any means demo means hands-on? Have you done any hands-on? Can you show that so that I can understand what are the pods and nodes and how they are working?
Yeah, we talk about Kubernetes in our courses, in our DevOps courses completely, how we deploy the applications of the Dockers here. So the flow actually works in this way that you prepare a Docker image using the Docker build command or using the Docker file here. You upload it up on the Docker Hub there. And when you go to the Kubernetes, and in Kubernetes also we have a kubectl command line which is available, using which we can deploy our applications. In fact, when in our particular trainings we cover a lot like those concepts. There is a full-fledged like a separate session for Docker and Kubernetes where we are talking about that how we are like deploying our pods, our containers, and these containers we are like simply going and deploying it up in the form of pods on the actual server there. So these pods are also like nothing but the containers only, but yes, the same Docker image is being used there. So I use Kubernetes a lot in my organization also, and we are running like 400 to 500, that kind of huge amount of containers in a production environment. So I'm following the same stuff, have a Docker image built out, upload it to the Docker registry, and then go for the deployment, and then my new changes will be deployed there. The best part is that I don't have to take care of any dependencies on the production environment. Everything will be inside the container or the pod itself. So I don't have to manage anything separately all along there.
Okay, so basically you are telling that in the my I means I have having Java Spring Boot framework. So means I am using means not implemented yet. So we can implement means we can build the Docker image as a whole means as a single unit, or we can use it for each microservice. We can have separate Docker image? It's up to me, right?
So it's the same microservices only we are deploying. Spring Boot is just a framework for the microservices in Java, which we are using so that you can deploy your application and host it up in the form of Docker container. And then you can just deploy it as many as microservices there. So it's a specific framework for microservices only.
Yeah, means I want to ask that suppose we have 50 services in my framework. Okay. And I want to deploy it. So can I deploy, means we can deploy it as a single with a single by building a single Docker image, or we can deploy means we can use one image for a one service. So is up to us,
No,
or
separate images for each and every microservices. We don't want to bundle them as a single one. If you bundle them, then there is no difference between virtual machine and Docker as such. Again, the operating system will become bulky. So rather than that, and also there will be a single point of failure also. If you want to have it distributed, then have it up on different machine.
you are telling that we have to means create separate images for each microservice,
Yes,
right?
yes, yes, yes.
Okay, okay, got it now. Thank you.
And Anuj, let's say we modify the Docker file, and do I need to delete the image and then build it again, or can just I hit the build
It
command
will
again?
replace automatically.
Okay. Does it even replace in the Kubernetes as well, or should I run the kubectl command again to make this image bin run?
No, there are some update commands in kubectl in Kubernetes where if earlier you're using 1.0, next you want to use 2.0, so you update it to the Kubernetes, and Kubernetes
Oh,
will automatically take care of the replacement.
understand. Thank you.
Every image has its own separate OS or kernel.
Every Docker image will have its own underlying OS.
Okay, got it. And you said that there will be a separate image for each microservice. So
Yes.
if we have to bundle that, then we have to containerize it, right? So there will be one container and many images as
See,
each
every
microservice
Docker
from
image,
the.
when you run a Docker image, you get a containers. So if you have 5 images, you will have ultimately 5 containers only. So container is not something that we are merging 5, 6 images or something like that. So container is just like a running instance of a Docker image. So if you have 5 images, then 5 containers will be there.
Okay. So what is that Docker Compose when we
It's a
merge?
way of deploying multiple containers. Like you want to deploy 5, 6 containers, you want to deploy 5, 6 Docker images as a container. So it's a kind of a utility, just a tool there.
Okay, got it.
Yeah.
Thank you.
Maybe like if you want to run 5, 6 Docker run commands, so it can automate you to do it in a single command itself. So some kind of stuff like that.
Okay, got it. Thank you.
And Anuj, in this scenario, where does the pod comes into picture?
In
Can we say,
Kubernetes.
okay, so we say the container is a pod in Kubernetes?
Yes.
Uh-huh. Okay.
In Docker, there is a common network, or it's a Docker container have a separate network. Suppose a network is not defined, then what happens? There's a default network. Communicate
There's a
means each
default
Docker container.
network which will be picked up. If you don't provide that, it will be default picking up there. Docker.
Okay, so each means they are communicate each other smoothly, right? No need to
Yes.
define any network.
Yep. Yep.
Okay, thank you.
Any more questions, guys? Anyone who is having any doubt? Okay. So, guys, every month we are conducting such webinars. You can follow us on LinkedIn and Facebook. The link we have already shared with you over the chat window. You will get the updates on the upcoming webinar once you follow us on the YouTube, LinkedIn, and Facebook channels. Further, please provide your valuable feedback to us on Google reviews and test pilot. Your feedbacks are actually helpful for us and our trainers. They motivate us, to conduct such webinars, more webinars in future. And so please provide it. It will not take much of your time. So we have shared the link for the Google reviews and trust pilot also over the chat window. You can click on those links and it will take a minute or so to give your valuable feedback to us. Thank you so much for attending this session. So follow us to get the more updates on the these upcoming webinars. Thank you guys. Thank you.